Be active. So, what is our new topic? Force and motion. The chapter Force and Motion was simply started by the group. Which group? Hawkins, Stephen Hawkins. So, this chapter contains sub chapters. Other chapters are there. Actually, heading is Force and Motion, but here is rest, motion, types of motion, uniform motion, non-uniform motion, and next one there is lever. I think there is lever also, right? Yeah, yes, lever. After lever, what is there? What is next one? Children, there nothing. There is pressure. After lever, there is pressure. After pressure, what is there? Barometers. Is this also under pressure? Then chapter completed. So we need to complete one more chapter. This force and motion, and next one energy in daily life. Then we'll be in free and phrase, free and tensionless position, right? Understood, Anand? Okay. So, in today's class, I think the presentators are going to explain these things. What are they going to explain? Once let's check here, then it will be easy for us to proceed also. And up to 3-4 days, I think there is minor disturbance in our classes. Afterward, there is full-fledged discussion. Here is rest and motion. Next one is types of motion. What are the types of motion? Uniform motion and non-uniform motion. Then what is next? Average velocity. There is a numerical problem also, and a reference point, relative velocity, and some numerical problems are also there, right? Then the acceleration, then positive acceleration, negative acceleration, uniform and non-uniform acceleration, numerical problem, and this portion is over, right? So without wasting time, let's welcome on the stage today's presentator. Who is going to present? Which one? That Newton's laws. Now Newton's law no you do, because Newton's law is not right now here. So next part you have to. Sorry? It was asked you to send earlier. Whole duty was given to this group or not? Then yesterday why didn't you do? Whole chapter is your duty. Yeah. Then yesterday you just sent one and it became rest motion. Chapter is rest and motion also. There is motion also. And next group they are not doing anything. Why? So you have to coordinate. Without coordinating, then how can you do? All members are there. There are two groups. Which group is this? Maintain this one. Which group is this? Newton group, and next one Hawkins. And there must be coordination. How nicely they have done earlier? Have they done nicely? So they were making slides and doing this and that. So there must be active participation. Then only work can be done. Okay, everybody, make backbone straight and listen. Whose copies are those? Keep that one now. Later you can submit. Keep that side. You sit down. Where is your place? Go that side. From there only. One work must be done at once, and works must be completed on time. Like next time, this group will prepare all the slides. They will present. Again, another chapter will be presented. This one, it is obvious. Duty was given early. Until now, the slides are not prepared. Then, when the work is not done on time, you will suffer. And you make them active. These are many more members are there. Only you have. Oh, the Sarvani Gautam. You have only got duty to do that. Who is the leader? The units. Why didn't you do?
Told them to make presentation.
Told them means where is that one? Told them means you have to be active on it.
I said we will make presentations of intervals. So like yesterday we made presentation and we said next day. So means
You have to send earlier. See, whole chapter was given earlier or not? Chapter was divided earlier only. Fourth, fifth, sixth was it was given. Was it given or not? And what are you doing at that time? Resting. Told, why told? You have to check whether it is done or not. Did you prepare yourself or not? Then, and the Sarvani, she made some slides, she sent. At least she has done some duty. Rest of others, what happened? You have to make them active. You are the leader. Leader must be attentive. Then only there will be outcome. Tomorrow, everybody, you just divide and give it to them, and their presentation must come. Divide the whole chapter into 8 different equal parts. Who is absent today? Sumit Suna is absent. Okay, divide into 7 equal parts. Give them duty. Matter is like that. You are smart for other things, not for studies. Why? Be smart in study also. Okay, so children, now look at here. Now next time onwards, don't repeat this one. And this group, you can work out on the chapter 7. You can work out on the chapter 8. And you can work out later on the chapter 9. Remember. Keep hand down, boy. Smart decision there, huh? Just planning to say smart, smart, smart. Okay. What is given here? 2 things are given. What is one? What is next? Motion. How to define rest and how to define motion? What is rest? What is rest? Sit correctly, baby. Are you at rest or motion? What do you think? Rest or motion? Actually, to say whether a body is at rest or motion, there must be another body. We have to compare, right? What do you think? The earth is at rest or motion? Motion, how? It revolves around the. So if the earth is in motion, are you in motion or not? Yes. Then why do you say that you are at rest? That's why, with which body you are comparing? Suppose a vehicle is traveling, right? A bus is traveling, and the passengers inside the bus, are they at rest or motion? Motion? How? Rest how? They are sitting, but the person who was sitting in the lodging part, they may reach in that Sundara. Yes or no? That's why, with what you are comparing. So, if you talk about you, you are at rest in comparison to that building or next pain, etc. But when you are compared with sun or moon, you are at motion. Our condition is the same. So, what is rest? How do you define rest? Rest is a condition of a body at which it does not change its position with respect to other body. If a body does not change its position with respect to another body, then the body is said to be in rest. And if a body changes its position with respect to another body, then it is said to be in motion. Position change with respect to other body, rest. Position remains with respect to same body or other body, what is it? Motion. Position changed, motion. Position not unchanged, rest. So, some of the example of rest are The vehicle kept in the garage. Motion, the vehicle which is moving in the road. The players are in rest or motion? Motion. Flying board, rolling ball, and swimming man, running water, motion. Water in a lake, water in a lake, rest. Water in your water bottle, rest. These are the examples, right? Example is from motion. Okay, body is in rest, body is in motion. But one thing we have to remember, rest and motion are relative terms. Rest and motion are, when there is rest, there must be motion. Understood or not? We don't get anybody at rest only or motion only. A body which is at rest, it may be at motion also, with comparison to other bodies. Here you can see something. Types of motion, mainly how many types of motions are here? What are they? Uniform motion and non-uniform motion. What can you see here? Here is your man. He is running. What is the distance A to B? B to C? C to D? 10 meters. And time? 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 1 second. He is running or he travels 10 meter in 1 second. 10 meter in 10 meter in. So 10 meter, 10 meter, 10 meter, is it equal or not? 1 second, 1 second, 1 second, equal or not? So, if a body travels equal distance in equal interval of time, distance equal, time equal. So, such type of motion is called uniform motion. If a body travels equal distance in equal interval of time, then it is said to be in which motion? Uniform motion. Second one, what is given here? Non-uniform. Your non-uniform motion. Let's check. At first, how much distance is here? How much time does it take? Second, how much? Distance is same or different? Time is same. Time is same or different? So, what can you say about non-uniform motion? If a body travels on equal distance in equal interval of time, if a body travels on equal distance in equal interval of time, then what is it called? Non-uniform motion. So, what is the difference here? Equal distance in equal interval of time in uniform motion, unequal distance in equal interval of time in non-uniform motion. When you depart from your home to school, what type of motion do you have? Uniform motion or non-uniform motion? Yeah? Non-uniform. Sometimes you travel a bit fast, sometimes you travel a bit slowly. Because you don't count and travel, right? Yes or no? But the athletes, when they run, at that time they may travel equal distance in equal interval of time. May. Yes or no? They are very fast, right? Okay. Now next heading is here. What is the next heading? Average velocity. So, if a body is moving with non-uniform motion, then we can get here one idea what is that average velocity. What is the definition of average velocity? The ratio of what is here? Total displacement and total time taken. What is given here? The ratio of total displacement and total time taken is called average velocity. What is the formula of average velocity? Total displacement by time taken, or AV equals to S by T. S means total displacement, T means time taken. For example, here is Susan. Susan travel 50 meter. Susan travel how much meter? 50 meter in 2 seconds. This is distance or displacement. This is time. If Susan traveled 50 meter in 2 seconds, then what is the average velocity? S by T. S is how much? 50 by 2 meter per second. Remember, distance must be expressed in meter, time must be expressed in second. Then how much does it come? 25 meter per second. What is that? 25 meter per second. Is it okay?
Yes, sir.
Remember. So, this is the formula to calculate average velocity. But there is another formula of average velocity also. Here we have to remember U and V. What is U? What is V? What is U? U is initial.
Velocity.
What is it? Initial velocity. What is V?
Velocity.
Final velocity. Oh, what is initial velocity? What is final velocity? Initial means at the beginning. Initial means at the beginning. At the beginning. Final at the end. At last. Suppose Ritik's initial velocity is 20 meter per second. What is the initial velocity? 20 meter per second. His final velocity is how much? 30 meter per second. At the beginning, his velocity was 20 meter per second. Now, how much is it? 30 meter per second. Then AV. AV means here is one formula. What is that? U plus. Earlier we wrote average velocity equals to S by T, displacement by time taken. Now what we have written? U plus V by 2. What is U? What is V? Now what is the average velocity here? Do you know? 20 plus 30 by 2 means 50 by 2 equals to 25 meter per second. Keep your hand down. Numerical problems must be stated in mind. Understood? Okay? Pay attention towards it. And when you read the book, you take the one highlighter or pencil. What is in your hand? You will get 2-3 slaps. Your teacher. He was the candidate who deserved the least marks in UT. 3 marks. Yeah, he knows. You have seen the marks also? Then you want to fail every time? Focus on it. His mind was busy in that caps cover. Counting money or what? Later on, or first study, complete master level, then you own your own business, then money comes. Khalasi, don't say Khalasi. Now for Khalasi also, person must pass class 10. AC pass only Khalasi, remember. Without certificate, no Khalasi. No Jao Guruji. Bhag bhai. License, for license you have to pass +2. Now Pathao, Jikao is gone get it. Offline, police will catch you and then keep it. There's this one. Sorry? Okay. So remember. So that negative mind don't open way. You have to be positive. How to bail every you don't think. Negative mind is Pathao is there. Khalasi is here. So many scientist groups are here: Newton, Einstein, Whittaker, Oppenheimer, Madame Curie, Niels Bohr, Hawkins, and Khalasi. Remember, eh? One conductor became very much famous, you know? Who is that? Rajinikanth. He was conductor in a bus once upon a time. But his style was very interesting one, and he got chance in movies. Now many people they regard him as a god. And you halasi, sui sui, huh? Sui sui there, right? Okay. So here is one numerical problem. How many numerical problems are here? Here are two. Three also?
Yes. No, two only.
Only two numerical problems are there. What are they? One is here
One man
and
runs 20
yes.
meters.
So okay, read question. Man runs 20 meter on a straight line. High velocity. What is this 20 meter? S. What is this? Time taken. B. What is the formula?
S by T. S by T.
It's very simple, isn't it?
Yes,
Right?
sir.
Okay, up to this much we have discussed. Page number. What is the page number?
100.
Page number 140, 41, 42, 43. This must read once again and start making your note. Okay? Come on.